Okay, so now we're going to talk about angles of elevation and depression. So, the first thing we need to realize is that elevation is when you go from one area and you go up, whereas depression is where you start up and you move down. Really, whether or not it's an angle of elevation, right, or if it's actually an angle of depression, depends on where you start, okay? And that's going to be this horizontal line that we're going to talk about. Where is the horizontal line from which we are starting? And that will tell us whether we're elevating here or whether we're up and we're actually moving down. So first thing we have to do is identify whether something is an angle of elevation or an angle of depression. So if we look at this particular situation, we've got 4 different angles, and we want to decide if these angles are actually indeed elevating or depressing. So we'll start from angle 1, and if you look at angle 1, we're going from this bird right here and to the person that's in the hot air balloon. So the horizontal line for the bird actually is here, and then it's looking down on, if you will, the person that's in the hot air balloon. So if you consider that the bird is actually looking down on the hot air balloon, then number 1 actually becomes an angle of depression. Okay, and then for number 4, we'll say from the mountain to the person that's here, we're going from this horizontal line, which would be ground level, um, up to this angle where the person's eyesight is in the hot air balloon. And so in that particular case, that would be an angle of elevation. And if we look at the got it questions, they say, okay, well, what about 2 and 3? Well, 2 and 3 is going from the person in the hot air balloon. Their horizontal eye line would be here, okay? So from here to the actual bird, right? That's going to be an angle of elevation, right? If we're going from the person in the hot air balloon and to the ground, and they're looking down, then that's going to be an angle of depression, okay? Now, the next thing we need to talk about is from elevation or depression, what exactly are we looking for? How can we use this in a real world situation? So the first one is we're using the angle of elevation for this wind farm here, and we want to know how tall this particular pole is. So we say, suppose you stand 53 feet from the wind farm turbine. So here's 53 feet, and that's our horizontal distance. Your angle of elevation to the hub of the turbine, which is here, is going to be 56.5 feet. So this is my angle, and it's an angle of elevation. So I'm going up this way. However, here's the thing we need to take into consideration. Our eye level is 5 feet above ground. So from here to the ground level is 5.5 feet, right? So whatever we get for x, we're going to have to add this 5.5 feet to it. Approximately how tall is the turbine? So for this, for 56.5, we are looking for the opposite side and we are given the adjacent side. So of course we'll use tangent. So I'll say, well, the tangent of 56.5 degrees is going to be equal to opposite, which is x, over adjacent, which is 53. So in my calculator, I'm going to say 53 times the tangent of 56.5. Okay, so I said 53 times the tangent of 56.5 equals x. So x is going to be approximately equal to 80.07, so 80 feet. Okay, now in order to find the true height, because this is going to be 80 feet right here, in order to find the true height of, I'll write that in black so we can see it, this is going to be 80 feet right here. In order to find the true height, I'm going to need to add that to the 5.5 feet. So the actual height of the turbine should be about 85.5 feet above the ground. So that would be my final answer. Okay, so we look at the got it question and same thing, the site of a rock climber on a cliff. So here's my person, right? And here's eye level for them. And here's the climber that they're watching climb. Okay, their angle of elevation is 32 degrees and their eye level is about 6 feet above, right? So this area right here to the ground is about 6 feet. Okay, so we're going to use tangent. We're going to use 32 degrees because we're looking for the approximate height. So we are looking for this height here. But whatever we get for height, we're going to have to add to the 6 feet, the feet above ground to eye level. So I'm going to say the tangent of 32 degrees is equal to 1,000 times h. Okay, so if I put that in my calculator, that means the height is equal to 1,000 times tangent of 32 degrees. Okay, so tangent 32 times 1,000, okay, is going to give me about 625 feet. So I get 624.869. So I'm going to say height is about equal to 625. So the climber is 625 feet plus 6 feet. So the climber is about 631 feet above the ground. So again, we just need to make sure we remember to add that distance above the ground to eye level in order to get the accurate measurement for that. Okay. Now, here we're going to use some angles of depression. Same rules apply with the angles of depression and the angles of elevation. If there is anything that we need to account for, like distance above sea level or whatnot, we need to make sure that we do so. So, in this particular problem, it reads that to approach runway 17 of the Ponca City Municipal Airport in Oklahoma, the pilot must begin a 3% descent. So 3% descent. So that means from our horizontal line, we're going to descend 3%. Okay, so we know that's going to happen. Starting from a height of 2,714 feet above sea level. Okay, so then sea level would be down here. Okay, and we know sea level is 0. The airport, however, is 1,007 feet above sea level. Okay, so if we're looking at the airport here, the airport is not at sea level. It is actually 1,007 feet above sea level. Okay. To the nearest tenth of a mile, how far from the runway is the airport at the start of its approach? Okay, so here's the airport here. We're going to descend, right, 3% to the airport, and we need to know what is this height here. Okay, what are we looking for here? So we say the airplane is 2,714 feet above sea level, and the airport is 1,007 feet above sea level. So that's a difference of 1,707 feet, which is shown here. So this is 1,707 feet. We want to know how far is the airplane away. So how far are they going to have to descend here, right, until they get to the actual airport. Okay, so we're going to say we have the opposite and we are looking for hypotenuse. Okay, so opposite over hypotenuse is sine, right? So I'm going to say the sine of 3% is equal to the opposite, right, which is 1707, right, over x. Okay, so after I rearrange that, x is going to be equal to 1707 divided by the sine of 3%. So punch that in my calculator. and I get that it is about excuse me, 32,616.2 feet. It looks like I'm looking for it in miles, so I'll need to divide that by 5,280 feet per mile, right? And it is about 6.2 miles away. Okay, 6.2 miles away. Okay, so if you are working at home, you can go ahead and start this particular problem, the got it problem here. We now have another airplane, okay, and the airplane is going to spot a lifeboat, okay. So we want to see exactly how far the lifeboat is. It looks like the airplane is about 3 kilometers in the air. Okay, this would be the horizontal line for the airplane, would be this way. And we're going from the airplane down, so that's going to be angle of depression. And it looks like the angle of depression is 26 degrees. So we want to know what exactly the horizontal distance is. So here is the horizontal line that we're starting from for the airplane. Here is the airplane's distance above, right? And here is the angle of depression here. And what we're asking is from here, from this angle of depression where the airplane's looking down, um, to where the actual boat is, what is the horizontal distance? So what is this distance right here that we're looking at? Okay, so here is what we're looking for. This would be D, if you will. This would be my degree, and this right here would also be equivalent to 3 kilometers. So 3 kilometers on both sides. Okay, so I have opposite given, and I am looking for adjacent. So it looks like I'm going to use tangent. So I'd say the tangent of 26 degrees is equal to the opposite, which is going to be 3 kilometers, over adjacent, which is D. So after some rearranging, I'm going to get that D is equal to 3 kilometers divided by the tangent of 26 degrees. So I'll punch that in my calculator. And I get 6.159. So D is about equal to 6.159, or 6.2 uh, kilometers. So the horizontal distance the airplane to the lifeboat right here is going to be about 6.2 kilometers. Okay, so go ahead and start the practice problems for this one. Be sure to check your answers. Bring your work to class so that we can review any of the problems that you had trouble with, and answer any questions between now and the test day.